Hello, welcome back to part 2 of Proving Special Quadrilaterals. At the end of this, you should be able to say I can prove parallelograms, rectangles, rhombuses, and squares. Okay, let's pick up where we left off. Okay, in the first part we did parallelograms and rectangles. Now we're going to do rhombuses and squares. So, first example, prove that B, I, R, and D is a rhombus. Okay, so first we got to remember what a rhombus is. A quadrilateral with all sides congruent. Okay, it's like a square that got squished a little bit. Okay. Next, so there are two other ways to prove rhombuses. If one set of consecutive sides of a parallelogram are congruent, then all sides are congruent, and therefore it's a rhombus. So if we can prove it's a parallelogram and prove that two sides are congruent, two consecutive sides are congruent, it has to be a rhombus. Or if the diagonals of a parallelogram are perpendicular, then it's a rhombus. Okay, so either way, we've got to prove that it's a parallelogram first, and then we'll pick one of those two to figure out how to show us how it is a rhombus. Either that, or you could actually go through and do the distance formula 4 times to find the distance between all of these and show that they're all the same. So you could do that as well. That works. That's probably just a little bit longer. So let's do this. Let's give ourselves a grid and let's graph these things. So B is at -5, -6. That's B. I is at -2, -2. Let's see. R is at 3 and -2. And then D is at 0, -6. That is D. Okay, so now we're going to connect all these dots, make our rhombus, and check and see if it really is a rhombus. Okay, so first thing, we've got to show that it's parallelogram, so we've got to find the slopes of all the opposite sides. Okay, so slope of IR and BD, and then slope of BI and DR. Okay, so slope of I to R. So look here, we've got a flat line here. Okay, perfectly horizontal, so that slope has to be 0 because there is no rise. It doesn't go up at all. So it's up 0 and over 1, 2, 3, 4, 5. It's officially up 0 over 5, which is 0. Okay, same thing with B to D, up 0 over 5. So 0 over 5, which is 0. So we now know that IR and BD are parallel. Let's check out BI and DR. So from B is the leftmost one, so we'll do the rise over the run, so up and down first. 1, 2, 3, up 4 over 1, 2, 3. So it's up 4 over 3. Doesn't simplify. Let's see, from D to R, we're going to go up 1, 2, 3, 4 over 1, 2, 3. So that's also up 4 over 3. So these two are also parallel. Okay, so we've proven that it's a parallelogram, so both of these are true. Now we either have to show that the diagonals are perpendicular to each other, so we could find the slopes of both of those and see if they multiply together to get -1. Or, let's see, we'd have to find the distance between these 2 points and the distance, say, between these 2 points and show that they're the same. Either one is probably pretty straightforward, pretty easy. I'm going to stick with the slopes one because we've been doing that over and over again. So let's do that. So we're gonna find the slope between I and D, and then also the slope between R and B. Okay, so let's do that. Okay, so from I to D, I is the leftmost one, so we're going to go down 1, 2, 3, 4 over 2. So it's -4 over 2, which is -2. And then B is the leftmost one to get up to R. That's up 1, 2, 3, 4. And then it's over 1, 2, 3, 4, 5, 6, 7, 8. So that's 4 over 8. Which equals 1/2. Okay, so now to see if they are perpendicular, to show that they're perpendicular, we got to multiply them together. -2 times 1/2, and they have to equal -1 if they're perpendicular. So if perpendicular, this will be true. Negative 2 times 1/2 is negative 1. Negative 1 equals negative 1. So, therefore, they are perpendicular. And therefore, this thing here, we have now proven that it is a rhombus. Okay, because first we proved that it's a parallelogram because these slopes match, so that proves that they're a parallelogram. And then we showed that this intersected here at a right angle. They're perpendicular because their slopes multiplied together to get negative 1. Okay? All right, we're going to move on to squares, but first let's take a little comedy break. All right. Here we go. Let's take a look at some squares. Okay. So we've got prove that FLIP is a square. Okay, so first thing, if you remember, a square is a quadrilateral where all sides are congruent and all angles are 90 degrees. Okay, so another way to prove a square is if consecutive sides of a parallelogram are congruent and perpendicular, then it's a square. Okay, so so we could go through and find the slopes of everything, and then show that. Then we'd have to find two sides in a row that are the same, congruent. So we'd have to find the distance. We'd have to use distance formula no matter what, and then also show that they're perpendicular. Okay, or we can find the distance between all of them, show that all of them are the same, and then show that at least one of them has a 90 degree, just show that one of them is perpendicular to the other. It really doesn't matter too much. You know what, we just did the perpendicular, we showed that they're parallelograms and then that they're perpendicular. We just did that on the last one. Let's do that, and then we'll also just have to add in that they're congruent as well. Okay, so let's plot these points. F is at -5 and 2. L is at 1 and 4. I is at 3, -2. And then P is at -3, -4. Okay, and then we got to show that that is a square. Okay, so here's our square. So we got to show that it's a parallelogram first. So opposite sides, we got to find the slopes of both opposite sides. Okay, so slope of F to L. So rise over run. Start with the left side, the leftmost point. Up 1, 2, over 1, 2, 3, 4, 5, 6. So 2 over 6, which is a third. And then P to I is up 2 over 1, 2, 3, 4, 5, 6. So that is 2, 6 also, not 2 halves, 2, 6, which is also 1/3. So we've shown that this side is parallel to that side. And now FP, F is to the left, so we'll go start with that one. Down 1, 2, 3, 4, 5, 6 over 2. So -6 halves, which is -3. Oops, that's -1/3 up there, sorry. And then L to I. L is the leftmost one, so down 4, 5, 6 to the right 2. So that's also -6 over 2, which is also -3. So that proves that this side is parallel to this side. So we've shown that it's a parallelogram. Let's see. We could go through and show that these are all 90-degree angles, but and a parallelogram with 90-degree angles could also be a rectangle, so we got to stick with this here. So let's do the consecutive sides of a parallelogram are congruent and perpendicular. So we can show that these are perpendicular pretty easily, because that's 1/3 times -3, okay, is perpendicular if 1/3 times negative 3 equals negative 1, and that does equal negative 1. So these are 90-degree angles, all of these. So the last part we have to do is we have to show that two consecutive sides have the same distance. So we got to actually use our distance formula. So let's do that here in a different color. So distance formula, if you remember, is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so we got to find the distance of two different sides. Okay, so let's do this. It's nice that we have this drawn, because let's do, say, let's do FC and say FP. We can do that. You can choose any two sides that you want, but let's do, I'm just randomly choosing those two. So sorry, not C, L. So F and L. So this on this first one is going to be x1, y1, x2, y2. Okay, so we're going to do distance equals a square root of 4, the x. 1 minus negative 5. Don't forget the double negative. It's a very common mistake there. And then y2 minus y1, so 4 minus 2 squared. So that's going to be 6 squared. And 4 minus 2 is going to be 2 squared. So that's 36 plus 4 is going to give us, our distance is the square root of 40. Okay, we don't have to simplify it. We can just leave it, because all we have to do now is just check to see that this gives us the same distance. Okay, let's do that in a different color, just so that we'll be able to tell what's going on. So let's change that to red there. So now we're going to do F and P. Okay, so F is still x1, y1. P is now going to be x2 and y2. Doesn't matter which one you choose for the first point or the second point, as long as you choose the 2 points. Okay, so distance for those. Distance is going to equal, so we're going to do x2 minus x1, so negative 3 minus negative 5 squared. So that's double negative turns into a positive. And then we've got negative 4 minus 2 squared. So negative 3 and positive 5 is positive 2. Right? Distance equals. And then negative 4, negative 2 is negative 6 squared. So 2 squared is 4. Negative 6 times negative 6 is positive 36. So the distance on this one here is also the square root of 40. So since those two match, and we showed that they were perpendicular. So we showed that they're perpendicular right here, and we also showed that two consecutive sides are congruent. We have now proven, therefore, FLIP is a square. Okay? All right. That is it for these here. If you have any further questions, please feel free to ask in class. Thanks.